Okay, let's continue. Okay, from last time we talked about the milestones of AI, right? So the last part is that in 2016, right, Google DeepMind's AlphaGo AI defeated the Go world champion Licedo, right? So that was because the previous one, Deep Blue, is also yeah, I'm not old enough at that time. But this one actually, because I also play the game Go, so it's also a big blow to myself, right? Because before that game, people have long considered that the complexity of the game Go is so high that it is really hard for a computer program to beat a human being. Actually, before AlphaGo, there are many other AI tools to play the game Go, but the performance is so weak, right? So they are far away from beating a human, even professional player, not mentioning the world champion, right? But you can say, actually, during the game, it's actually really hard for Licedo to find any opportunity, right? And after that, the master Go and defeated Ke Jie, right? So another world champion, very easily. And so very quickly that the DeepMind announced that they will no longer further improve it because right it's already better than all the human beings and significant. So there is actually no chance for a human to win at this time. Right. So after that, right, you probably heard about the people talk about Turing test, right? So about 10 years ago, AI somehow they passed the Turing test computation, but that was not very convincing. Nowadays, I think the large language model like ChatGPT, right, already is much better and probably can pass the Turing test. Right? Medical wise, right? Robot passed the national medical exam. Right. Also, here AI beat human radiologists, right? At looking at those X-ray image, right? So image area, right? AI can do better than the human doctors, right? So that's one area the job can be replaced. Right. Also the medical devices, right? So those are. Of course, we can. Yeah, this is a part we probably want to add a little bit more of the new news. So let's come to this one. Let me share another screen. Okay, so three major tools for the large language model nowadays, if you are not familiar. One is ChatGPT, the most recent version, the GPT-4o. Google has a Gemini, and there is another tool called Cloud AI. Right, so my experience is that it's actually fairly good. Right? So what I'm trying to ask is a question like, what are the milestones of AI development of AI just since 2017? I can ask the same question for all the three AI tools, and then we can compare and also try to combine the message we get. Right. So you can see these are the results, right, from ChatGPT. Right. 2018, there is something called BERT, developed by Google. Right. Actually, I think before that they have the 2017 they developed Transformer. That's probably even more important. And for DeepMind, they developed AlphaFold. Right. AlphaFold is a very successful example, right, to predict the pattern folding. Right. So before the two, this was a big area of research. Right? Some world famous researchers, they publish papers in Nature Science, right, by just doing this one. And now it's almost completely replaced by AI. AlphaFold can do better than the AIB, the researcher. So actually, that means those researchers are suddenly out of job, right? So they don't have work to do. But for the society, this is a big advance, right? Because the the AI to apply that in science exploration, so we only have a limited number of successes. Right? This is one. And 2019, right? They have a GPT-2 and the Alpha Star. Yeah, I should get this one in the slides. Yeah, later I will accommodate those ones. Right. So to that now they have a GPT-2, even though right GPT-2 was not that famous, but it's under development. Right. So the Alpha Star is doing that in a real-time strategy game, right? StarCraft. Right. And next year they have another two, right? The GPT-3 and AlphaFold 2. And 2021, that is DALL-E. DALL-E is basically generate image right? Instead of just the text. Right? And they also have the code. You see, most of the development are from either OpenAI or DeepMind. Right? Right? That is a situation, right? The major development nowadays are dominated by a small number of companies. Right? In 2022, I think something by around the end of 2022, right? OpenAI released GPT 3.5. This is the first time that is a very powerful chatbot, right? And quickly become a very useful one, very popular. And it's less than 2 years from now, right? The 32 and the GPT-4, the performance further improved. And you can see there are other tools like a Cloud. Later we will see the performance there, and also Llama. Right? Llama is from Meta and it's an open source model. Before we go there, this is starting. Right? DALL-E can generate image, so we can ask it to generate an image of AI milestones from. Let's see what we will get. It will take some time. Meanwhile, while waiting, we can look at Cloud AI, right? Cloud AI have a similar result, right? So, but you can see it's also a little bit different. Right. So this Lambda, right? Probably you still remember the news, right? So this Lambda, a Google employee, right? Feel like this is already kind of a emotion AI, right? So they have similar to human beings. So basically, he quit or fired by Google. Later, they have a ChatGPT, right? And Google actually have another one, the PoM. So it's very large. You say 540 billion parameter language model, but the performance is not that's good. Right? The stable diffusion is a technology actually behind the DALL-E. Right? And the GPT-4 is much better. The BARD going into Gemini, right? So Cloud also keep developing, right? So the Cloud 3 now we are using now is very powerful. Right? Multimodal AI. Now AI can not only just do text, but they can do image and audio, right? So here, actually you can directly say audio to it. Okay, so this is a two. Right. How do you like it? Yeah, this one is not that good, right? But this one seems better. You're like ChatGPT, right? So, but it's also the number are not that good. So this is an area they can further improve. Finally, let's see the answer from Gemini. Gemini gave us answer, right? AlphaGo 0, right? Because okay, from here you can see some preference, right? Some bias, right? So each company's too is slightly biased towards a product of that company. AlphaFold, right? Lambda, right? So different too. Okay. Yes, the Darley, yeah, the text in Darley and also in the video generation tools, right? So also this is very hard. I think what's the name of the company? So last year there was a very let me see. So maybe I can find it for you guys. This remind me that what's that? Yeah, I just forgot the name. Anyone can remind me? There was a what is that? Yeah, so many things going. Deeper AI, no, that's yeah, never mind. So basically, the reason, yeah, Sora, yes, yeah, thank you, Sora. Let's see what's Sora currently doing. No, Sora is part of OpenAI, right? Never mind. But the reason I want to mention this one because even for Sora, for all those video generating, also how to handle text is a big issue, right? Because here, if you look at the traditional ones like image, right? So even though there may be some issues, right, in the background, right? So we cannot tell. But if there is some word there, some text there, we can easily tell whether it's good or bad, right? Like this one, right? For other part, you feel good, but for the text, you can easily see the issues. Okay, this is also because right, they didn't use a separate text generator for the text. I think that's the root cause of the issue. Okay, let's come back. Okay, so with all those great improvements, right? So what I want to share with you the slides, right? Showing here, right? So this is how the technology change over time, right? So the first stage is called technology trigger, right? So you start from R&D, and then you go to the startup company, first round of VC funding, and you get the first generation of product, high price, lot of issues, right? And then you get the early adopters, And then, but at this time, because this is a new technology, right, you start to have mass media hypes begin, right? So that is the issue, right? Because the media report, right, is a kind of a positive feedback loop. And whenever they say something, they start to make it larger and larger, right? Also, they say how rumor, right, from the on the social media network or even in our in person, right, the rumor will keep going into the extreme case, right? That's partially the reason they start to create this kind of peak of inflated expectation, right? So, right, while the technology is keep improving, right, maybe it's a line like this, right? But the problem is that right, the after some time, the expectation is much higher than what the technology really is. Right. So that's why after a while, right, so when it's at the peak, that is the most dangerous period, right? Because the technology cannot meet the expectation. Right. And then once it start, people realize, okay, we cannot deliver the expectation. Actually, the technology is still developing very well, right? So over time, but it's just our expectation can go really high, right? So that is the issue. We start to have the negative press and a lot of failures, right? Then you need a second round of VC, and then you go to the disillusionation part, right? Where people get very frustrated. And then we go to the second generation of product, and it's better. And at this time, not many people care about this one, but it's keep increasing. Until a point, suddenly people realize, okay, the third generation or even the fourth, fifth generation is good enough. Then it's actually go to the stage that it's work well, right? But you may go to several kind of this up and down cycle before you reach the productivity stage, right? So and also this change a lot. People are very bad at doing this prediction, right? Let's look at this one. This one is the Gartner. It's probably the most famous company doing this prediction every year, right? So they have the hyper cycle for emerging technology. They release it every year. This is what I have in basically 7 years ago. Right? So at that time, you can say they consider VR as already here, right? But after 7 years, right, we are still right not that close, right? Yeah, there are some videos on YouTube that you can watch using VR technology, but other than that, right, so the major development of VR, right, like the Apple's headset, the Vision Pro, actually stopped, right? So it's actually longer than we expected, AR and VR. Meanwhile, the peak they talk about is deep learning or machine learning, right? So those are great. Right? It's actually the case. Right? It's there. Edge computing is still not sure. Right? So another technology there, let me say, 5G is a technology that is probably there may be some issue, right? Because originally 5G promised a lot of good stuff, but it's actually not that easy to deliver. Right? Currently, you feel like you probably didn't feel the change from 4G to 5G, right? It's just maybe the speed is a little bit higher, but that's all. On the other side, 4D printing, I have no idea where it is now. AGI is also far from, it's more than 10 years, right? Deep reinforcement learning it's not bad, right? Quantum computing they consider also far, but it's actually developed fast, developed very fast. This blockchain, And at the year 2017, they consider blockchain already going down, right? But later you know that from 2017 until now, the blockchain technology developed a lot, including the cryptocurrency. So basically, I show you guys this one. So some of them are right, but some may not be right. Many of them may be wrong. But you can also say how it change quickly year from year, right? You may expect, right, those technologies stay there and just slowly move, but it's not the case, right? So this is the one for 2018, right? Some technology no longer there, right? For example, where is VR? VR in the previous is here, right? We expect to be a little bit, but we didn't see it. Right. Others like deep learning is still here, right? Even though it actually goes back a little bit. I don't know how that can go back, but anyway, 5G is here, seems promising, but still, right? And AGI 4D, right? So some technology is still there, but they have something new, right? Where is autonomous driving? Level 4, right? They put here. And yeah, that is still very hard for autonomous driving. Okay, this is 2018. This is 19. Right. So 2019, you can say the 5G is big, right? But the 5G now still, right? VR, the AR, they all disappear, right? So here, explainable AI start to be here, right? Low Earth orbit satellite system, like the Starlink, right? Some other ones, right? But I should tell you, right, from what we say, during this time period, we already have GPT-2, right? But from here, you say nowhere, like anywhere we have something like this? No, right? Basically, they didn't realize that one as well, right? So even though they have a lot of AI, but none of the AI is like the large language models related, right? Right? Even generative, right? So at that time, they still talk about the generative adversarial network, the GAN, not the generative AI. Right? This is a 2020. Right? Similar. But here, finally, they have this generative AI. Right? Also, self-supervised learning become important. Right? We discuss with the data, right? And where is a blockchain? I didn't say it. But this is a year actually Bitcoin become very important. And all those cryptocurrency based on the smart contract also become popular. Right? But you say it didn't have anything here. But the next year, they start to have something called non-fungible tokens, NFT. But if you know the history, right? So then later next year, that one goes nowhere almost. Right. So sorry, this is stop at 2021. Let me give you what happened after that. Right, so we can look at 2021. We already have 2022. This is from 2022. You can say, right? So this one NFT goes down, right? But generative AI at the year 2020, it's actually at the beginning, right? So because 2023, there is a big jump in from the ChatGPT, right? But you say in 2022, still not there, right? So we didn't say they make it very mention that one, right? And let's see whether they have it in 2023. Right, this is the one from 2023. Right, generative AI suddenly go to the top, right? And because the AI, the ChatGPT, right? But this one is also, let me see. 2024 is supposed to be out, but let me check if we get it or not. Okay, great. We actually have it 2024. Okay, let's look at this one more carefully because this is the most recent one. So from here, you can say generative AI, they already consider it's going down, right? So I think that is along with many, along with the idea of many of us. Because the problem is that it's really hard for AI, so generative AI, to deliver something beyond the chatbot and those kind of simple tools. But what we really need is for AI to do more for scientific exploration of our daily life, right? Those ones are still not that easy. Right? But you can also say something related, prompt engineering is here. Right? So also it's a light blue, means that it should be very useful in 2 to 5 years, right? Probably the case, right? So if you are familiar with prompt engineering, you know it's not that hard. AI augmented software engineering, that's also there. Right? Cloud natives, what else? AI, this is about the trust or responsibility, something like this. Reinforcement, AGI is still there. Highlighting is larger than 10 years. That's the guess. Right. So basic means the company expects the answer to our question last. So basically I asked you the question, right? So do you believe we will reach AGI in the following decade? Right? So in that sense, you can have your own idea. But in this one, basically the company bet it's longer than 10 years. Right? AI supercomputing definitely coming. 6G is coming, but the problem is that we still haven't figured out how to use 5G, right? So not mentioning 6G. Spatial computing was there from Apple, but now it seems even longer, right? The digital twin of a customer, right? So this is the figure we have for this year, right? So basically, in the slides I gave you in the past 7 or 8 years the data, right? So you can look at those, right? So you can with that change you can see more information than just look at one of them. And also when you select your project topic, you can use this as a reference. That's a starting point. Okay, this is what we will do. Okay, first part, let's talk about cloud computing. Right. So cloud computing has different ones. The two most important one is called infrastructure as a service. Right. And there is another one called the software as a service. Right. Of course, there are many others. Right? Nowadays, machine learning as a service or something, medicine as a service. Right? But for our course, we focus on these two because these are the first one, infrastructure as a service. This is more like the Amazon style, right? So Amazon, as I showed you from last time, when they give you the resources as a service, it's basically you get the machine, right? This is an infrastructure. Then you can use the machine to run whatever you want. Right? So they give you both the hardware and the system software that you can use them to provide your own service. On the other side, the software as a service directly give you the application. Right? So anyone can give me example of a software as a service? So our first quiz is not far away, right? So yes, Microsoft. Traditionally, what do you need to do? You need to download the software, install on your computer to use, right? But now you can directly use the software, right? The Microsoft like Office, you can use a website to use it. Dropbox, yes, but the AWS service probably not. Right? I just mentioned AWS is actually infrastructure because there you didn't get the software, you actually get the machine. And be careful because if you, as I mentioned, we will have the quiz in 12 days, right? So you want to be more prepared. Zoho, yeah, I haven't used Zoho. What is that? Let me check. Oh, I see. It's a cloud software suites for businesses. Yeah. Also, you think about, let me see the chat. Yeah, Copilot by GitHub, right? Others, Spotify, and also ChatGPT, right? That is a software as a service, right? You just use the website. You didn't install anything. Everything is actually done remotely. Right? Nowadays, we will see more and more software as a service, right? Because that is probably by default the future delivery of software, right? So it's less likely that you need to install something on your computer, but you can just use a web browser to use it or some API. Okay, so the property of the cloud computing is first one, you get the illusion of infinite computing resources available on demand, right? So that you don't need to do the provisioning ahead of time. Right? Whether you need 1,000 server or 1 million server, you have the illusion you can get it now, as long as you have enough budget. Then, it also eliminates the upfront commitment by cloud users, right? So you don't need to build the data center, right, before you can use it, right? You can directly use it. And also you just pay for what you use, right? So if you only use, say if you, sometimes you need 1,000 server, right? But if you only use it for 10 hours, you just pay for those 10 hours instead of for all the, for purchase all the resources, right? And then if you use for 1,000 server for 10 hours, then only 100 server for the remaining 14 hours for the day. Then during that 14 hours, you also only need to pay for that 100 servers instead of the 1,000 server to use at the peak. Right. So now the situation is that the cloud provider like Amazon or Azure or Google, right? They provide this infrastructure, right, to the cloud users. Right? Then the cloud user will use the resource to develop a software, and they will become the software provider, a SaaS provider. And then the user, like us, we will just use the web to access to the resource, to the application. So the application will run in the cloud instead of running on your own computer, right? That is a key difference between software as a service versus a traditional software. Okay, there is a question, right? What's your opinion on the long-term affordability of software in the SaaS model versus buy once, own forever? Yeah, this is a great question, right? So actually, we didn't do the calculation last time, right? Maybe we can do it now, right? Since you asked this question. So not only just for SaaS, it's for the infrastructure, there is a problem like this. Okay, so this is EC2. Let's go to EC2. Share this one. Let's find one server and let's also look for a server, like for example, from Dell. Okay, and this server, for example. Right, you can get a server by yourself, right? So let's just let's choose one. Maybe the first one, right? Let's see. The configuration features. Let's see. Want to get the configuration. Yeah, this is a CPU. Right, the CPU seems has a. This is a very cheap one, right? Only $759. Right? Let me make it a little bit better. Right? So add $100. Okay, so now this one go to 4 cores. Right? So let's look for the EC2. We need to get 4 cores. This one, and the memory current 8. Let's also go to the 16. Right, so now it's like this one. So okay, but if you do this one, let's look at, right? So about this amount, you can do the calculation, right? Times 24 times 365, right? So in 1 year, you basically need to pay $1,177, right? So the storage, we haven't got storage yet, right? But the other one, you need to pay for electricity, right? So we basically assume these two may be similar, right? So basically means if you buy the server, you pay $1,000 almost, and you get it. And you can use it for 3 to 5 years, if not longer. But if you go to cloud, you pay over $1,000 for just 1 year, right? So that is a caveat, right? So that if you do the on-demand one, right? So you may get the a very high cost if you use that all the time. Right? Actually, if you use that all the time, you should consider this saving price, right? So right? So based on 1 or 3 years, right? So that is you can save maybe 30%, right? What we talk about the other one. Right. Oh, you just do the reserved one, right? Which one are we using? On demand. We were talking about this one, right? T4G X large, T4G X large, right? T4G X large, this one, right? You say you get some discount, 30% roughly, right? A 30% discount, you still need to pay $700 per this one. If you reserve it, right, similar, right? You still need to pay roughly $700, right? So basically, that's an issue, right? If, of course, you can say the Amazon also take care of the server, right? But if you can manage the server by yourself, right, over the 3 to 5 years, if you need to use it all the time, it's beneficial to purchase it once. But the issue now is that for software, right, come back to our side. But the issue for the SaaS, right, software, so nowadays they don't give you the option, right? You can purchase it and then not pay any future, right? All the cost is very high, right? The issue is that if it's very high, then I mean, the company may disappear, right? May die during sometime in the future. And so also from the company, they also want to see the steady cash flow instead of a burst and then you no longer have anything. Right? So that's also give the SaaS software to have the motivation to keep developing. So there are pros and cons for that one. So this maybe is related to a problem issue. We don't have time to go over, but this is a second rental problem, right? Whether you purchase it, pay one-time cost, or every time you go there, you just rent the equipment, right? So it's unclear which one is better, right? It really depends on the case. Okay, but that's a good question. Yeah, I think this one another interesting story is that in the old days, people give the airline company, they sell the ticket that they call it an unlimited ticket. Basically, instead of buying a ticket each time, you can just purchase once, and then you can use a ticket for the rest of your life, right? You can unlimited. Then the company quickly realized the issue of that. Basically, you get the money now, but then you have a very long unlimited liability into the future, right? And for the customer who purchased that one, previously maybe he just take 10 flights, 20 flights per year, but now he can take 2,000 flights for the year, right? So that's the issue, right? So, right, so many things there, right? So especially for SaaS. For the SaaS, the provider also need to pay to use the cloud resources, right? So if you don't get the pay, and as time going, right, your demand, resource consumption actually increase. So if you just charge once, then over time you probably have incentive actually make the software worse, right? So save some resources, which is not the right way to go. Okay. Okay, let's go back to this one, right? So this we talk about the cloud. There are two types of cloud. One is private cloud, the other is public cloud. Right? This is also we want you to make sure you understand the difference. We may ask you a question, give to tell whether it's a private or public. The private is like a Google data center, right? So of course, Google data center have both private and public, but they have the data center used for their own use. For example, to serve, let me make it clear for Google search. Right, for this one, right? So it's a data center, but it's for its own use. It doesn't want to share with others. So this is a private cloud. Right? It still have many properties like the public cloud, but it's not basically you don't pay to use it, right? So if you work in Google, then basically you can use it, right? But the public cloud is like AWS or Azure or Google Cloud, right? Yeah, let me put it here, the three ones. Right. So basically here, it's open to the general public. So we can all use as long as we pay, and also pay as you go manner. It saves you the upfront cost, time, and the personnel, right, to take care of it. And it also solves the problem of over provisioning or under provisioning, right? Because without this, let's consider a startup company, right? So how many servers you need, right? If you build your own computing room, right? You don't know. You may under provision. If it's not enough, then your performance may suffer. That's not something you want to say, right? Because the customer may have the complaint and they may leave your application or your system. Right? But on the other side, if you are very cautious, you put in a lot of servers, you may have the issue of over provisioning. So many of the servers are just idle there, but you still pay a high cost. Right? So those are very big issues, right? For startup in the old days, before we have cloud computing, and now, right, no problem, right? So no matter how many servers you need, just use this. Right? Once you go to the steady state, right, and you can also replace partially of your resources go to your own private cloud. But nowadays we see more and more because the startup company grow very quickly. They just don't want to develop their own data center. They just use the public cloud. Right. Okay, but you should say that there is a difference. You want to evaluate. Once you go to the cloud, then you want to say, okay, the user hours, the basic number of hours you want to use the cloud, times the cost of using the cloud, right? Or the revenue minus the cost, right? That is what you get from there. Or if you use your own data center, right? So the user hour of your own data center also times the revenue minus the cost of your data center divided by utilization, right? If your utilization is almost 100%, like when you use the cloud because you can adjust, right? Then it's just your cost. But the issue is that your utilization might be low, then your cost may be very high. Right? So that is an issue for your local data center. Right? This is what I showed you here. Right? So the resources, right, ideal case like this, right? You just do the provision of the peak, but still, if you do this, the shadow area is where you have a low utilization. And the diagonal pattern, right, for user is very natural. Right? If you develop some applications for human to use, right, you should expect there will be some diagonal pattern go up and down, right? So that's not good for you to have your own one, right? Because you are wasting a lot of resources. But if you do the on-demand, right, instance, then you can do like this, right? as long as your resource provision is higher than what you need, you are okay. By doing this, you can keep it a very high utilization, right? And also this save the cost. Okay, other scenario like we mentioned, under provision, this part is an unsatisfied demand, right? Normally, those users will give you very low review, and that's a big disaster for the company. Right. This is also the situation very bad. Of course, you may have another situation that is the opposite, right? So your provision at here, at the beginning it's good, actually you are wasting resource. But after a while, it's go higher and higher, then you have an issue. Yeah, let me see the chatbot. Okay, so the question is that due to Moore's law, we have seen equipment costs for overtime. Yes, that's always the case. Probably will be there for a long time. Production company style shift to most long-term contract with cloud provider. Such that private buyers have to pay a individual premium for them to pay. Yeah, that is happening actually, right? If you look at the actually for Dell, it's actually they are in a very challenging situation, right? But if you look at the chip providers, because data centers, they probably won't directly purchase a server from Dell. Actually, they purchase some of them, but they are more likely to directly purchase the CPU, GPU, and also the storage from the vendor, like AMD or NVIDIA or Intel, right, or the disk providers, right? So they can build the server by themselves. It's not hard actually, right? So you probably, some of you may have the experience. You just buy each component and then you can build the computer by yourself. It's much more cost effective, and also it gives you a lot of flexibility to choose the equipment, right? So in that case, we do say, for example, if you look at the financial report from AMD, right? So their revenue from the cloud provider or data center actually increase a lot, right? So instead of selling direct to users, now they make more money to selling to the cloud providers. Yes, we do see the trend that those vendors selling more and more to the cloud, to the data center operators, instead of selling direct to user. Actually, if we have more and more SaaS, the future, our own computer, is just an interface, right? For us to be able to browse, get access to the web. And then all the computation, or most of the computation, will be done in the data centers. Right? In that sense, most of the equipment will also go to the cloud. Okay, come back to this one. Now from the user like this, but from the cloud provider, right? Do they also have this issue, right? The answer is that they have a much better situation because they have many users. And the users' demand are not synchronized. In that sense, when some user has a peak, some other user may have valley. Right? So doing this multiplexing combines them, the demand is much more flat, meaning that their utilization can be higher. Also, as we mentioned, the cloud provider also have the support instance, means that when the utilization is low, they can have a reduced cost for some user to use those ones. Right? This is something you cannot do as an individual user. But as a cloud provider, they can do it to increase the utilization. Okay, now we go to data centers. most of the material here are from the data center as a computer. Right? So the first question is that why not using a single machine? Right? So actually, Twitter is an example. They keep using a single machine. Right? Whenever they have more users, they just upgrade the single machine, make it more powerful. Right? But eventually they reach a point, right? Because there may be too much user data compared to their storage capacity for a single server, right? And there may be not enough I/O bandwidth because you need to read a lot, right? And meanwhile, you write a lot, right? Even computational capability is not enough, right? So this force Twitter eventually go to the distributed platform, right? But of course, if you have a single machine, the benefit you get is that the software is much easier, right? But nowadays, for the many cloud computing, the SaaS software, right? They expect to have a lot of users, right? So a single machine is definitely not enough, right? Consider ChatGPT, right? Now they have 200 million active users, right? So if only 1% of them is doing asking the question, right? That basically 2 million prompt, 2 million basic questions there, right? And each GPU, right, probably can handle several of those questions, right? So, I mean, if you want to wait for a server to have thousands of GPU, right, or to wait for one GPU to handle thousands of prompts simultaneously, right? That's not doable, right? So that's why, as a result, the ChatGPT, they actually use Azure, the cloud system, right? Partially because Microsoft is basically the owner of OpenAI, right? So the tie is very strong. So they basically use Azure for doing their service, and they use thousands of GPU in a distributed manner to serve user requests. Right? The distributed manner is both that the model itself is too large, it needs to be break down onto multiple GPU, and also the user requests too many of them, so they need a large number of these copies right, to serve the requests in parallel. Okay, so and also what's going into a machine, right? From here you can see what I have is also the old version, right? It's changing now, and basically you have the CPU, right? That go to the memory bus to the main memory, and then go to PCIe or some other I/O connect to either SSD or the hard drive. Right? SSD is much faster, right? But the problem is that it's much more uh, costly, right, compared to the traditional hard drive. And also goes through the internet, they are connected to others, right? And the capacity bandwidth is also very different, right? So going to the main memory is very fast, but going to others is much slower, right? So the internet. Right? It doesn't include the more advanced technology, right? But since here we can look at the technology. Let me show you the give example. Yeah, I put the link in the slides so that you can look at that. Okay, this is a DGX2. Right. So this is a single server, but you can say it has a 16 has a VR100, but the GPU memory combined together 512 gigabyte. Right. So this is a number of cores there, and also it's connected using NV switch. NV switch basically makes the communication very fast. And you can say here within from the across the GPUs and the GPUs with with CPU, right? So now they can have reach this speed, right? 100 gigabyte. Right? So this is comparable to the main memory, right? Also storage, they use NVMe SSD, right? The capacity is 30 terabyte. Internal storage, right? So the SSD is basically 2 terabytes. What else? The CPU, right? You see the CPU, the frequency is not very high. We will see quickly why this is the case. But there are 24 cores, right? Memory, 1.5 terabyte of memory. So network, right? The infinite band is within the network. It's basically the NV switch. And then this is the capacity connect to outside other servers. Right? It's fairly heavy, right? So 360 pounds, right, for just one of them. And the power usage, you see this one, the 10 kilowatt, right? So for one server. The traditional server is a 200 watt, 0.2. So it's 50 times of the traditional server, just for a single one. Right. Also the cost, right? They said their cost is this is the baseline, but I think this one costs also at the level of maybe 200 or 300,000. Right. Of course, the performance, right? So if you do rest stat training, right? If you use CPU, that take you 500 hours. That's probably too long. Using the first generation of DGX, 5 hours. Now it's 2 hours. Actually, from 5 to 2 is not much improvement, right? Because DGX 1 is only 8 GPU and it's much cheaper. So for example, we can check the DGX 2 price. Right, you see, initial price is 400,000. This is the how large the system. Right. You can look at the. They said only 400, but it's not cheap. Okay. Okay, you can see the change, right? So this 100 gigabyte per second is still very hard to achieve, right? So that's basically what they are doing now. The GPU is also connected, but this one is much faster, right? And the storage is also much larger. Basically, this is some student asked about Moore's law, right? So Moore's law, from this figure, you can say clearly this is there is a line, right? And the x-axis is a linear, and the y-axis is exponential, and it's a log scale. So it's stated by 52 years ago by the founder Gordon Moore, right? So basically realize that when the law was defined, this is something very interesting, right? So let's say Okay. So this is the point he saw at that time. Right? 1, 2, 3, 4, 5. Okay. Given this 5 point, can you get Moore's law? Right? I bet it's very hard, right? But you see, later ones, fairly at the beginning, it's not very linear, but later it's become linear. Right? Anyone can guess what happened? Small transistor or yeah. So this one again, right? This law is not like the physical laws, right? So there is no reason why it need to be the case, right? This is mainly later, right? Intel becomes a kind of a monopoly in uh, the chip development, right? In the CPU, right? So that they basically define the plan like this. Right? So this is what their objective, the KPI. Right? So once they set it, at the beginning it's not like this, but once Intel becomes the dominator in the industry, it's everything will centered around that. So basically they will set a plan like 2 years, we need to double the number of transistors. And all the other industry to do that, they will make their go according to this one. As a result, if you are going far behind of this, you definitely need to catch up, which is good. But if you are ahead of time, what should you do? Right? If you can actually make it more than double, but Intel tell you just to double, then that's not double, that's width there. As a result, you see this artificial, it's basically a man-made linear line. But you say later, that is the issue, right? The Intel CEO claimed that it's no longer 2 years, it's close to 2.5 years. That means it's actually slowed down, which we can also see from here. Right? And during the middle, actually, you see just several points, perfect linear, right? So that is the issue that I think if you look at, let me show you another one. Can you see this one? This is the Intel stock price. Right? Till the year 2000, before that, it actually grew very quickly. Right? Because once they are monopoly, they get a lot of profit. Right? But at that time, right, even if they can do better, they didn't do until they actually now have competitors, right? Like AMD is a competitor for the CPU, and there are others for the chip manufacturer, right? Like there are many other companies doing better than this one. So as you can see, right, now recently they are doing very poorly, right? So there is a comments in the chat saying that we are running against the limits of physics. It's not there yet, right? Because you may heard about the news saying that we are already close to 2 nanometer technology, right? But the Moore's law didn't mention that the size of the transistor. It basically means that you need to double. To double that, right, you can use different material. The different material may have a smaller size. This is the manufacturing technology, right? That can put on more transistors. Also, now people are exploring the 3D technology. Right? Traditionally, just one layer, but now you can put multiple layers. So basically, from what I learned, that the Moore's law, from the physical constraint, it can run for a long time. So there's no problem with that. But the problem is that now is that whether you want to do that or there may be other challenges. Right? But basically, what you can see is once a company as big as Intel, once the kind of dominant area, right? But now they suffer a lot, especially with nowadays most computing go to the GPU part. Okay, the GPU. Okay, actually, besides that, the transistor gets smaller and smaller. The fundamental problem is that the power density. It just becomes hotter and hotter. Right. So this is a standard scaling. Right. You can say the transistors also keep increasing, right? But the power part, you say around 2006, at this point, they start to become flat. Right? Means that they cannot afford even higher power, right? Because you need to get the heat out of the chip. Otherwise, right, the high temperature may cause the chip failure. Right. So it's also at this time, people start to decrease the frequency. At this time, you will see the frequency like 4 gigahertz, right? But nowadays, 2 gigahertz is probably common, right? Instead, to compensate for that, because the frequency no longer keep increasing, to compensate for that, they start to have a multi-core system. Right? Traditionally, it's always have only one core, but now you can see that they can have tens of cores. And for doing that, they keep adding the transistors on that one. Right? The heating is a big problem. Nowadays, for GPU, right? Even for GPU, right? GPU, they have thousands of cores on the same chip, right? But to get it to cool down, it's also challenging. Now there are liquid cooling, right? Means that there may be some pipes contain the cooled waters there for the cooling. But also there is more recently emerged, something like that. Basically put the computer just in some liquid for the cooling, right? It's all from this problem. Also last year, there were some news about the super conductivity materials, right? If there are materials like that, that's also great because, right, the reason we have a lot of heat is that there are resistance in the system all over, right? And when the current goes through, it generates heat, right? But if they can be built using superconducting materials, then there's no heat. Then you can keep increasing the frequency and adding more transistor, right, to make it more powerful. Right. But unfortunately, this law scaling basically means as the transistor gets smaller, their power density is still the same. They broke it around 2006, meaning that if you make it even smaller, it means for the same area, you put in more, right? And the power density actually start going up, right? So that is a big issue. Yeah, let me check the chat bot. The quantum quantum level, that's again another myth, basically. We are no longer there yet. And so, and also I think the technology now they are currently applied is going from 3 nanometer technology now to 2 nanometer to 1.5 and keep going down. Right? And meanwhile, they use different materials and do the 3D technology. Right? So like this one, right? the memory already go to 3D. Right? So instead of, because we do need more memory. Actually, for GPU, a key metric is the GPU memory. Right? So that traditionally, if you only have one layer, now I can have multiple layers. Right? So clearly that can increase the memory storage. Right? And also for GPU, traditionally they have L1, L2 cache within within CPU. Now they have L3 cache, which is a much larger one in the CPU. And memory with traditional DRAM, now you see a lot of non-volatile memory. Non-volatile memory means that they want the memory to keep the material, keep the content, right? Keep the data, even if it lose power. Right? The current memory, once you are out of power, once you come back, you need to go from start, right? There's no data in the memory, right? But the non-volatile memory want to have that. And also SSD is another one. The 3D memory is a technology, right? So now within one server, it's also become more complicated. Okay, I think I will stop here. And any questions? So I will share the slides, but start preparing the first quiz, right? We may ask you a question in the slides. Okay, if no more questions, by the end of this week, you need to submit your team members. I will create a white space assignment for that one. And yeah, also start thinking about your project idea. Yeah. We will discuss that later. Okay, see you next Tuesday.